Our next speaker is Rodolfo Carvalho, who comes from Rio de Janeiro. He founded Coding Dojo Rio community there. He has been living in many cities, including Lisbon, Beijing, Cracow, and Brno, where now he works on OpenShift, the open source platform as a service at Red Hat. Rodolfo will dive into the art of deployment. Modern deployments, Rodolfo Carvalho.
Thanks everybody for the warm welcoming. First thing, I wanted to thank the organization and congratulate them. They're doing a great job. I think everybody's enjoying the event. Am I right? So the topic here, I like that and yesterday and today we are listening to the presentations and we see a lot of connections, right? In the previous talk, somebody asked about IPC and then, oh, it's gonna come in the next talk. And during yesterday and today, I saw that deployment was also some topic. Like people were talking about you build your application, then you need to deploy this. There was some discussion about OpenStack. How do you make it like your very smart network? And first thing I wanted to ask, just to have an idea, I want to know who here is familiar with some of the things I'll be talking about. And since I can't see you very well, I would like to ask you to clap your hand if you know OpenShift, if you have ever heard of it. How about Kubernetes? Okay, so less. And how about Docker? Okay, so I think everybody knows about Docker. And the cool thing about OpenShift, it builds on top of Docker and Kubernetes to create a great experience for developers to deploy their applications. And I will show you, in particular, Python applications. So, you know, before coming here today, not very long ago, I was living in Cracow still, in Poland. And I was working as a Python developer, building microservices. Also, I believe a lot of you here are doing this today. If not, you are migrating your monolithic applications into microservices. And doing that, one of the things that amazed me the most was how we can take that very complex system made of 30, 40 different services and make it work as a single piece, right? The end user, they just, like we heard about Facebook, right? Facebook, big infrastructure, but for the end user, you're just scared that you go to facebook.com and you see one application. And to make all that work, at least in my case, I had a lot of DevOps, very talented people that could provide us developers with like a one-liner that you executed and you have your application deployed in testing environment or staging environment or production. And we were able to do that all the time. But I believe not everyone have such good DevOps in their team. Maybe you can't afford it, it's expensive, right? So now I changed roles. I'm not developing Python microservices anymore, but I decided to give the same experience that I had before to other developers. So my role is sort of a developer caretaker inside OpenShift. And cool thing about OpenShift, normally when you talk about a platform as a service, you go into this, you lose the flexibility you had before, right? Before, when you had your Puppet scripts and your custom deployment, you could do whatever. You could use multiple technologies. And yeah, you just need people to make all that wiring of things work. And when you choose a PaaS, like you choose Heroku, for instance, it's very easy to get your simple application with Django and database working. But if you want to do something more complex, you're like, okay, that's not really possible. It wasn't made for that. But OpenShift v3, which is what we are developing now, is different. And it's essentially different. It basically lets you run whatever that you can run in a Docker container and wire these things together. So you could have a complex microservice architecture with multiple frameworks like Django and Flask together, talking to message queues, databases, whatnot you have, and even other languages. And just with a very simple one-liner or some UI, you could deploy this and make it available to your customers. So cut the crap, and I will just show you, this is the very dangerous part of the talk, and it's also the longest part, where I'll just show you the real thing, so no more slides. Can you see it well? So this is the web UI for OpenShift. I will log out here, just you see how you would start. So we start from the principle that your system administrator installed OpenShift on your cluster. It can be installed on top of bare metal, virtual machines, OpenStack, and a million other things. And here I have it on a virtual machine on my laptop. I can log in, and the first thing you see is a list of projects that you have access to. To be safe, I decided to create 2 projects here. I have one that is already running and one for the live demo. There are some problems. There might be some problems with internet connectivity. But the idea is that you go to your project, and then you have it. You have this. You have an empty project, and the easy way is to create some application from a template. I will go and explain the details as we go. But I'll just get started and install a Django application. You can define your own templates. You can customize a lot of parameters, for example, where you're taking code from. So yeah, I just one click and I have my application deployed. So this is what I'm talking about, like modern deployments, where you don't have to mess around with a bunch of things and uncertainties. Things might take time because of internet, so I'll just switch to a already deployed project. So in this example, what I have is that sort of simple application. I have a Django project and a Postgres database. So what happens when I click there to create a project, it will automatically create a database for me, which is here. And it creates 2 instances of the Django web application. So let's try to understand each of these pieces. It's first thing, Kubernetes. Kubernetes is it's a project from Google that lets you manage containers in a cluster. So OpenShift exposes all the primitives from Kubernetes. So one of them is this idea of a pod, which groups containers together to say this is one useful thing I want to do. You can think, okay, this is, for example, the Unicorn server or your database server. And then you can say, you have a deployment config where you say, okay, I want to run 3 of those pods or 2 of those pods. In this case, I'm running 2 pods for the web and 1 pod for the database. You can say, what is the deployment strategy for that? So if you want to do rolling updates, what are the constraints for the success or failure of the deployment? And on top of that, you have services. And services, they basically, like you don't want to talk about when you have multiple instances of pods, so you have multiple web servers, Django web servers that can serve your request. You don't want to talk about each of them independently. You want to talk about them as a whole. So you have this concept of service that gives you a stable IP and port. So whenever you want to talk to web, you just go to that IP, and it will round robin and dispatch the request to one of the pods that can serve that request. So actually, like after I have the thing running, I don't know if the other project will ever succeed to build. Not yet. I will show you like the application. So this is actually like a very normal Django application as you would get from doing a Django tutorial. And so there are little details here. Can you see it well? I'll make it bigger. So first thing is that I'm showing here the host name that serves this request. So since I have two instances of it running, whenever I reload the page, like now I have the ZV and I have the 1.4 ZV, and they are alternating. So for every request, I'm having a different server serve this request. I'm also showing information about the database that I'm connected. And this application is simple. It's just storing the database, a number of page views, and it's incrementing the counter. So the idea of this is to help you get started with Django. Like you fork this project. I'll show you the URL later. So you basically fork this project, and you can start building your application. One more thing when you have a PaaS service is that sometimes you have to do a lot of follow special patterns, or you have special restrictions in your code, and here you don't. So you can have a normal Django application that you start, where you already have, and you give it to OpenShift, and it will deploy it. It will put it inside the Docker container, and then you put the container in your infrastructure. So I want to show you how, well, one thing you normally want to do is scale this. So now I have two instances. What if I have more traffic and I want to have more instances to serve more traffic? So for that, you can use this OSC resize command. So we have here the Web3 pod, so I can say OSC resize, and I tell the number of replicas that I want to see. Let's say 10 replicas for replication controller Web3. And then we go here, and now we have like 10 servers running. And this is also one interesting aspect about Kubernetes. You don't tell it like create eight more instances. You just tell it what should be the state of the system, and then it takes care of figuring out what is missing to converge the specification to the current status. So if, for example, your application would die, and you say that, okay, you should have there 10 copies, and you happen to have 9, it will just create a new one for you. And conversely, I can say, okay, now I want to scale down. I don't need 10 anymore. I just need 1. And it will kill all the rest, and you go back to having 1. So you can write like scripts to automatically scale up, scale down, depending on whatever you want. If you are the administrator of the cluster, you also have access to this default project that exposes internals of the system. So you have the Kubernetes and Kubernetes read-only service that you can use to query the API and see information about resource usage, traffic. So you could use that to write a custom script to run tasks like having more replicas of a certain service. And the Docker registry is where you store the Docker images. You can either have it on Docker Hub, so everybody If everybody knows Docker, probably everybody knows Docker Hub. So you can either use that, or you can use your own private hub. Okay, so going through all the other concepts in order. So, okay, back to that project. So there are a lot of concepts here. I want to try to make it like simpler. That's normally what I try to do. Like I see a complicated thing and I try to think, okay, what are the more tangible things I can think about? So one of the concepts there is a build configuration, and here is the image of one. And what do you need it for? You need to get your code and make it into a Docker image, right? That's the thing that eventually runs in your infrastructure. So the build configuration, you have 3 strategies with OpenShift. One is to use, one is called from source. So you provide the source code, and we'll figure it out if it's a Python project, if it's Django, Flask, whatever. And we automatically create a Docker image for you, so you don't have to have a Docker file or anything. That's probably the easiest way to get started. The other strategy is to have a Docker image already. So if you already have other ways to produce a Docker image, you can start from there. Or you can have a custom method where you provide your own scripts to generate a build. That's the third way. And the cool thing here, you can have triggers. So there are at least 2 of them I would like to talk about. One is GitHub. So whenever you push your code to GitHub, you can set up a trigger that will cause a new build of your code. And then you can have a trigger for deploys. So then it will give you that experience of pushing code and having it deployed automatically. You can also trigger a build with the configuration change. So if, for example, you change anything here, like for example, the source of your code changes for whatever reason, it will automatically fetch the new source and redeploy. And the last option would be image changes. So this is the case when you push a new image to the registry. So that could happen, for example, when you do it when you do a manual build of the image, and then by knowing that there is a new image, it will automatically start the build. And well, the cool thing we have here that is particular to OpenShift and not on Docker is the concept of image streams. Because on Docker Hub, you can just like upload the image, and then after that, like you have no notion of history or something. So if you update a new image, you have no idea what was there before. So you and there's no system for doing hooks. So there is no way to say, okay, when there's a new image, do something. All right. So we add on top of the Docker registry, and we create this image stream which basically tracks the history of images. So it's the same as the registry with some enhanced functionality. So after build, you have the actual deployments. In the deployment configuration, you tell what is the template of a pod. So we basically say which containers belong to this pod. In the case of a database, you just point to a database image. It could be either something that we provide, like based on RHEL or CentOS, or you can tell your own image that you grab from Docker Hub or you build it yourself. And the same for your code. So when you have your other your deployment configuration for your code, you just say so what kind of containers you need to run. You say how many replicas do you want, and what will be the strategy for performing the deploys. So there are a bunch of things you can do. Like, of course, as an administrator, you can control quotas, permissions, users, teams. I'll not focus on that. I think my idea here was more like Brandon was saying in the morning, that until you see something, you might have heard of it, but it will take some time until you actually try to use it. So my idea is mainly to, show you how this thing works, how easy it is to get started. So maybe you can, like, after today, just take a look and consider using it. So I talked about flexibility, but I demoed a very simple application, right? I just show you, there is Django and there's database. And because that template I wrote, it's a simple template with just these two things. And whenever I'm using this, like I'm actually developing OpenShift. Like I joined the team about a month ago, so I'm still in this kind of learning time, and I think this is very cool because I'm getting an image from like an external developer. Like how does it feel to develop and deploy on OpenShift? And like every time I'm seeing like, I could do something very cool with this. So for example, a friend of mine, he made a demo for etcd, which is a distributed key value store, running in cluster mode. So you could have this as a template, and so in your infrastructure, whenever you need a new etcd cluster, you just click a button, you have it. So there are no limits to when in your template you can define what pieces need to be built, how do you want to deploy them, how are they wired together by saying specifying ports or shared volumes. And this for me is like very there are no limits to what you can build. So just to sum up, and I want more to have you ask questions. I want to sum up like with the parts that we saw. The first of them is the application template. Actually, it didn't show you any template, but this is just a big piece of JSON like this. So this is the template from which I generated my Django application. You normally don't need to write a template. The template is for simple applications, the template is given for you. If you want to configure like a more sophisticated system, you just write your own template. You specify, for example, which services you have, and then you declare build configuration, deploy configuration. So I'll not go into the very details of the JSON structure. But yeah, as I said, having the possibility to write a template, you can configure how any application looks like, no matter how many components you have. The build config is the important part to go from source code to Docker images. So I don't know here, maybe you're already doing that. I was doing that before to isolate. So whenever I was deploying, somebody talked about Falcon, I was using this, and yeah, we did use this in production. And the first way to test that was to have Docker images and just run Falcon on PyPy. So it was easy to specify, how do I run my code? Which, apart from the Python dependencies, what other system dependencies do I have? So in the build configuration, you kind of go from, I have source code. How do I make a runnable container, which is this magical thing that just works anywhere? Then we have the deployment config, which I will have strategies. I will define, so how do I deploy the code? Again, just like build, you can have, I didn't mention all of them, but you have a rolling strategy, which will do a rolling update, so it will start deploying new instances of your code, and then gradually killing the old ones as the new ones are ready. You can have recreate, which is basically the simplest one. It just kills all the old ones and recreate new pods for your new code. Or you can have a custom strategy where you define also with total flexibility what you want to do. You can also specify the number of replicas in the start, and you can also change this on runtime, right, to scale. And you define the pod template. The pod is basically a concept in Kubernetes for a group of related containers that will run on the same host, be it virtual or not. And a service abstracts those pods, giving you a fixed IP and port that you can access some service. So for example, your database or one of your microservices. And one more very interesting thing that we have there is the concept of label. And all of those previous things I said before, they can have labels. So whenever you're talking about things, you don't have to talk to them by pointing their names. So it's very inconvenient when you have hundreds or thousands of copies of things, right? Like you don't care about that container that is running there. You don't care what is the name of all of your 1,000 containers in your cluster. You just say, okay, I want to, for example, shut down all the containers that are labeled test. Right? So having labels on the things makes it very easy to select and talk about things in groups. Yeah. So the code for this example is in this Git repository, the second one. If you want to know more about OpenShift, the whole source code is available on GitHub/OpenShift/origin. It's very easy to get started. You just do like a vagrant up, and you have a virtual machine with OpenShift running where you can try this example. Last thing before questions, Red Hat is hiring. So if you ever want to move to Brno and work with me, you're welcome. Let's talk. Yeah, and with this, I finish presentation and I open for questions.
It's on. Hello. You mentioned rolling upgrades, rolling deployments. Do you have any metrics you're checking to ensure that the new instances are actually running? So that, like, how does that work? Like.
Okay, so that's a good question. I will complement before I answer that. You can do the deployments. You're normally thinking about updating code. The other thing that can happen is when, for example, you're deploying some broken version. And what you want to do is roll back. And this is supported. Like you can, since we're keeping track of everything, you can easily roll back to the previous version. And back to your question is, how do you know if the next version is already ready before I start killing the others? So there are two things in the configuration. For each container, you can specify a liveness probe and a readiness probe. So you can pass there an arbitrary command. Actually, there are multiple types of probe. I remember now like an arbitrary command, like command line. So if you need to run some script to determine if your service is running, you have a HTTP probe, which do HTTP request. Normally, I think it's only for get, is HTTP get. So you try to get some endpoint. So you can code in your application some health endpoint that tells you if the application is healthy, and one more to tell if it's ready. Right? So you have these two probes. And the third one is a TCP probe. So you not only, OpenShift is not only made for HTTP or web applications, you can deploy arbitrary stuff. So you have also a TCP probe that can check on some TCP port if it's ready or not. Okay.
Hi.
Okay.
You said you can run it on top of virtual machines and OpenStack and bare metal and everything. Can you run it on top of like Amazon Web Services?
Yeah. So if you go to this repository, the Vagrant file we have, it also has configuration for Amazon. So you can run it on VirtualBox like I'm running now, or on top of Amazon infrastructure.
And will that work only with EC2 or other Amazon services as well? Like if you want to use something else for your deployment, like, I don't know, RDS or something like that.
Sorry?
If you want to like use different services from Amazon, because you can deploy it on EC2, or can you like mix other services as well?
Yeah, you can do anything, in the sense that this will like if you configure your network and you can access external things, you can use them, right? For example, S3 for storage, or there's no restriction.
Hi.
Sorry, there is one interesting thing that I learned is how you can do a sort of infection, that you can have already your cluster with OpenStack running, or your like Amazon infrastructure configured, and you can install OpenShift in one of the nodes, and then make it control the rest of the cluster. And I think this is something that shows how you can like, it's like a Trojan horse, right? And I like this.
How it cooperates with Ansible, for example?
How it compares with Ansible?
Cooperate.
I think it doesn't. Like,
Doesn't.
yeah. So how does it compare? Like Ansible is more for automating things, right? And well, you could build your own platform as a service, and part of it would be Ansible. But this is a lot more than just automating deployment process, right? Like yesterday, I remember someone said about using Fabric. You can also use Fabric scripts to run a deployment, but this is usually only good like until you have if you start to grow much, like for example, the service I was working before, like I think you don't want to use one script, like one handmade script to deploy 30 services together and make sure they know where the other one is and so on. Right? It gets very complicated. So probably that's when you want to use a platform that already takes care of a lot of other things, like collect metrics and so on.
Okay, thank you.
Hi, I have a question here. Here, first row. Yeah, I have a question about load balancing, because when you bump the replicas to
Hello, welcome after the break. Hope you like it. Now we'll be going back to the questions and answers in modern deployments talk.
It was so hot that it melted, right?
What was the question that has been interrupted?
Here. Yeah, so I think it's to repeat, right?
test. Okay. So my question was about load balancing. Is it our responsibility, or is there any support on OpenShift side?
Yeah, so when you have a service, you create a service, it's basically managing IP tables to do round-robin dispatching for all the pods. So whenever you add or remove a new pod, Kubernetes will automatically update the config. So there is no like extra, like you don't pay any extra price to have load balancing. If you need more sophisticated load balancing, you can install your own load balancer as a pod, right, as a component of your infrastructure, and then you have it dispatch requests to your other services or pods.
Okay. Hello. We know how it's with applications, but how OpenShift work with databases, for example? Can we scale databases, or it's any batteries include for that?
Yeah. So with databases, we will provide out-of-the-box experience. We already have demos with MongoDB, with MySQL, like a cluster of MySQL, with Postgres, with Redis. And basically, you can also roll your own, like you can build your own image. And for example, with Postgres, I didn't change the number of replicas because what would happen would be very funny. Like you have 2 Postgres masters that don't talk to each other. And depending on to which master your application is connected, like you write data in one place and it doesn't get read in the other. So you could read from the other and then like you have inconsistent application. It's probably not what you want.
So we must implement these behaviors on a template.
Yeah. You would, for example, have a single master, and then you have another component, which is a slave. The slave is configured to connect to the master, and then you can easily like scale the number of slaves. If you have like other types of storage, like etcd, it doesn't need a master, so you can just have as many etcds as long as they know where like the others are. It would work. So it depends on the technology you're using.
Okay, thank you.
Hi, I have a question, or actually 2. First question is, can I run this on bare metal?
Yes.
So I can actually have my own cluster of servers and then put OpenShift on it and then just run stuff on it.
And it's very easy to install because it's only a single binary with everything like Kubernetes, Docker. Actually, you have to have Docker, and then everything else is in one binary, including the web UI.
So it's not bare metal. So I have to have something like CentOS on the machines and then
No, you don't have to.
All right, okay. And the second one is with the Docker containers, sometimes you need to mount directories from one Docker container in another Docker container, so there's dependency between the containers. Can you map that in OpenShift?
Yeah, in that case, you want the containers to be in the same pod. That's the reason for the pod concept. I think I may not have explained it that well. Like, you could think, okay, I just need a container, and then I have 2. I change the number of containers, right? I multiply it by 2, 3. But that would be a bad thing because it's good to have this pod layer that basically says these things here need to run together. So for example, you have a PHP container and then a PHP myadmin, which is a common group that you want to replicate together. So that's where the concept of pods come in. So yeah, like can you repeat please
Well, the idea was that you sometimes need to mount directory.
Mounting the So within the pod, you can say like which volumes you want to mount in the containers. So you can share data across containers. Yes.
Okay, perfect. Thanks.
We still have time for one question, so this will be the last one.
Hi. I don't know very well all of this administration stuff, and can OpenShift help me with all these configurations files like Nginx, WSGI, or domains configuration, or I need to configure all by myself?
Okay, so you can run OpenShift on your machine, and that would be like good enough for you to test it. But probably if you want to run this like in production, you want to have people that understand about like this kind of settings. But then you as a developer, you just care about deploying your code, and it automatically, for example, with a GitHub Rook, it automatically know that you deployed, and it will build and that you pushed code, and then it will build and deploy your new code. The idea is that you as a developer makes your job very easy. You still need somebody to configure OpenShift for you if you want to run like a serious deployment of OpenShift.
Thank you.
Thank you very much for your talk, Rodolfo.
Thank you.